Now we want to move on with more question. This is quick review. See page 35, chemistry KBSM textbook. Alright. So given Avogadro's constant 6.02 times 10 power 23 per mole. Now the question is, what is the meaning of molar mass? Alright. So let's zoom in and find out more. What is the meaning of molar mass? Okay, the word molar seems to imply mole. Alright, in case it is, let's repeat this again. I've said this before. One carbon would have a relative atomic mass of 12. Relative atomic mass is only one type of scale. Okay, it tells us something about a relative scale, comparing one element, one atom with another atom. So if you can put all the carbon together, many of them, okay, to the point of 6.02 times 10 power 23 pieces of this, if you could put them together on a weighing machine, you probably get the reading. No, you will get the reading of 12 grams. So 1 mole of these atoms will give you 12 grams. Alright? So if you have 1 mole of this, it means you have 6.02 times 10 power 23 pieces of this, and all these pieces, they have the mass of 12 grams. Alright? So the actual mass depends on how many mole, because 1 mole will give you that. So this one, it has an official formula of 12 grams per mole. That is for carbon. Carbon has 12 grams per mole, and this is what we call a molar mass. Okay, we call this a molar mass. So actual mass can be obtained from using how many mole times the molar mass. Okay, this is what we call molar mass. Mass of 1 mole of atoms. That is what we call molar mass. Alright? So what is the mass of 0.01 mole of ammonia gas? Alright, so maybe I can work things out here. I don't have to go to the whiteboard. So I use this one to give you the formula. Remember, actual mass is number of mole times the molar mass. Alright, this is a molar mass. So using this formula, we can find the mass M here. The mass of ammonia gas would be 0.01 times ammonia gas. This is 14. This is 3 times 1. So you get 17. So what do you get? 0.17 gram. 0.17 gram. Okay, I think we should use whiteboard instead. Okay, so NH3, the relative molecular mass is 14 plus 3, so you have 17. But if you have, this is just one piece, one only. If I have 1 mole of this, I definitely would have 17 grams. Alright? So the actual mass is number of mole times molar mass. Okay? So given 0.01 mole, and the molar mass of this is, for NH3 ammonia gas, is 17 grams per mole. Okay, now we truly understand why the mole and overmole, they cancel each other. Therefore, you get 0.17 grams of ammonia gas. Alright. So let's go to number 2. number 2b, 6.02 times 10 power 24 nitrogen molecules. Okay, what is the mass of this? This one is a bit tough because we need to relate 4 things. This one is a big N, right? Number of mole is big N over Na, actual over standard. It can also be mass, actual mass over molar mass, which is the standard mass. Alright, so now our aim is to get this. Do we have this information? Yes, it is from here. This is always given. Nitrogen molecules is 14 times 2, 28. So it's 28 gram per mole. Alright, so we go to whiteboard. So this one, the RMM, to be more exact, is actually 14 times 2, 28. But in 1 mole, I must have 28 gram per mole. I mean 28 gram. So the official molar mass of nitrogen gas is 28 gram per mole. Now, the formula, number of mole, is number of particles over Avogadro's constant. Number of mole can also be actual mass over standard mass. My main aim is to find this one. My main aim is to find the actual mass. Now I have this information, and this is given in the question, and this one is 28 gram per mole. Okay. The number of particles given is actually 6.02 times 10 power 6.02 times 10 power 24. Alright, so let's rub off this one to make way for calculation. Alright, so this will be a case of 6.02 times 10 power 24 over 6.02 times 10 power 23 equals to mass, the one that you are looking for, and this one is 28 gram per mole. Alright, so to get M, you can cut this off, you're left with 10. So 10 times 28, 280. Maybe you will feel that this is a bit tough, so I suggest you use another method, which is find the mole first. Find the mole first. So you have 6.02 times 10 power 24, 6.02 times 10 power 23. Okay, you can cut this off and get 10. And now you write this again, number of mole is mass over molar mass. And it's 10 because you get it from here. Alright, now you know, then I'll just rub it off. Then the mass, actual mass, the molar mass of nitrogen gas is 28. Alright, so the actual mass of nitrogen gas is 10 times 28. Maybe you would think that doing it one by one would be better. So it's up to you, it's your choice. Alright, so with this choice, you can choose between the two, which one more suitable for you. Okay.